Hello and welcome back to my channel. This is the part 3 of our small program in which we classify images of handwritten digits using PyTorch. So let's get started. In a short recap, in part 2 we pre-process the data and getting them ready for machine learning, deep learning, and in part 1 we load the data and we visualize the input data. Okay, so let's go on with part 3. In the part 3, we create the network architecture that we're going to use in this project. First, we define a class called net, which is a child of a parent class torch.nn.module. Okay, then we define the initialization of this child class. So init self, and we need to input the size of the network input size. The basically it is the shape of the training x train or the features data. This is about 28 by 28, so that is the input size, and the output size will be 10. The 10 is the what you call this the number of outputs. Basically there's 10 digits from 0 to 9, so it will output that one. And the hidden size, or how large are the number of neurons inside the layers. Okay, so as you can see in the next lines, this is just a super that init. This is how we initialize the parent class. Okay, so another way to do that is this one. Initialize it in directly torch.nn module, which is the parent class, that init itself. Okay, next is we create the layers. Okay, in this network architecture I'll just have about 3 layers. Okay, the first layer we're going to it's a linear, and it will have an input size defined here in the initialization, and the hidden size also. In the second layer, the input will be the size of the hidden size, and it will still output the hidden size also. So for example, the hidden size is 100, then it will output also 100 numbers. Next is the third layer, which is of course the input size is the hidden size, and the output size is the number of outputs. Okay, the number of outputs here is 10, basically 10. Then we define the activation function. Each neuron has an activation function. Okay, so here we use the activation function gelu. Next, we initialize the weights. Okay, so we initialize the weights using this definition, these methods. So init weights, so we initialize the individual layers. FC means fully connected layer 1, FC2 is fully connected layer 2, and FC3 is fully connected layer 3. Next is we define the method for forward propagation. So the forward propagation will need to have an input of features like the X train or X test. So basically that is 28 by 28 numbers of features. Okay, and we put it inside this as an input to this fully connected layer 1, and the output will be transmitted to this activation function, and its output will go again in the fully connected layer number 2, and so on and so forth until it goes to the fully connected layer number 3. So the output of the fully connected layer number 3 will be the output of this forward propagation. Okay, so we'll just run this one. The next one is define the network. We have already the architecture, then we next is we create an instance of that class object. So classifier is an instance of the class net, which is the net class has input size of 28 by 28, as I said earlier, and the output size is 10, and I put this at the hidden size of 400. You can do other hidden number sizes of uh, neural network nodes, so it's up to you how many you put it here. Next, we define the loss function. Okay, the loss function will be the one to see is how much how much is the loss or the error in one go. For example, it will compare the output of this network of the forward method, and it will be compared to the labels or the white train data. And based on that, the loss function, we need to minimize this loss function. Okay, so the one to differentiate those is this criterion. Basically, here I use the cross entropy loss, and it will be summarized and reduced to the average loss, so it's mean. The next is we define the optimizer. The optimizer is the one who's going to compute the gradient. Okay, here is I use the stochastic gradient descent, and the parameters I pass is the parameter of this object classifier from the class net, and the learning rate I put it at 0.001, and a momentum of zero point 0.9. In order to further this is optional below. In order to further maximize the accuracy of the model, I make there the learning rate scheduler. Basically, this modifies this learning rate from the minimum of 0.001 and the maximum of 0.01. Okay, this is small, bigger than this one, but after a few iterations, it will use this up to this one. Okay, so we just need to run this one. Okay, now we are going to train the network. Okay, so basically that's it for all for now. See you in the next video.